Good morning and welcome to part 3 of our multiplication and division lessons. I realized when we were going through the multiplication and division that there was one part that we were leaving out that was very, very important for students to understand, which is the fact families, those relationships between multiplication and division. Now, students started looking at this on the 25th of February, so this is a very new concept for them. And I'm going to show you how we broke it down in class for them to understand. Now, in this case, we did not start with a multiplication problem or a division problem. We actually started with the numbers in a given fact family. So I know that we've worked with 4 times 2 in our multiplication and 12 divided by 3 in our division, and we're actually going to go back to the 4, 3, and 12 because that was one of the examples that we worked with in class. Now, how we did this together, I'm going to kind of fold my page here just so that you can see how the notes were formatted, and I'll actually show you my notebook to show you what this ended up looking like when the students took notes, because we took it in Avid 3-column note format. Which students are very used to doing. We do Avid 3-column notes a lot in class just because it's a very good organizational tool. All right, so let me draw my dividing lines. And I actually need to fold this one more time. This is just a general good way for students to make the different connections between everything. So we're going to have, in this column is going to be our numbers. So in this case, we're going to have 4, 3, and 12. In this column is where we're going to represent the 4 equations. So they need to have blanks for the 2 multiplication equations and blanks for the 2 division equations. And then in these boxes, we're going to represent the 2 multiplication equations, and the bottom 2 are going to be our 2 division equations. Now, I like to start with multiplication because they understand the concept that when you multiply, you're making something bigger. Division, you're making something smaller. So I have them look at the numbers and I say, well, what 2 numbers do you think we're going to work with that are going to build upon each other to create the largest number? And that's when they call out, the 4 and the 3. So I'm going to start with 4 groups of 3. And once again, with the multiplication, they need to make sure that they start by drawing their groups down. So I'm going to do an array. So there's 1 group, 2 groups, 3 groups, 4 groups. And I have my second and my third in each group. And you can even have the students come in behind themselves and, just like we did before, recognize that I have 1 group of 3, 2 groups of 3, 3 groups of 3, and 4 groups of 3. That is perfectly fine. And then they need to make the connection that we have 4 groups times 3 in each group, which equals 3, 6, 9, 12. They're then going to take that equation and plug it in over here. Now they're going to come to their second multiplication problem, which this is when they need to realize that for an array, this is when it gets flopped, because now we have 3 groups of 4. So I'm going to start by drawing my 1, 2, 3 groups, and I need 4 in each group. And again, lots of students need that connection of drawing the groups because they're not quite to that abstract point where they can see it without physically drawing it. So feel free to have your students physically draw this. There is nothing wrong with it. I am a full proponent of that. So now they need to understand that I have 3 groups times 4 in each group, which also equals 12. And they're going to fill it in. And this is when I have the conversation with students that if in multiplication you're doing repeated addition, division you're doing repeated subtraction, when we know when we're doing subtraction, we always start with the biggest number. And I even spread my arms really, really wide and I said, in subtraction, we start with the biggest number, shaking my arms out as wide as I can possibly get them to help them make the connection that if division is repeated subtraction, then just like in subtraction, we need to start with the biggest number. So we're going to start by drawing our 12. And in this case, I always try and draw the first one like this one to help them see that connection. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to say, well, I'm going to take those 12 and I'm going to divide them and I'm going to put 3 in each group. So once again, here's my trusty matte pencil. I've got 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3. And so now they can make that connection that there are 4 groups. By this point, when they're filling in the 12 divided by 3 equals 4, most of them start recognizing that, hey, there's a pattern here. We're seeing these same numbers over and over and over and over and over again. Most of the time, by the time we get here, when we're drawing 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know that I'm taking 12, and this time, again, I need to flop 2 numbers. I'm dividing them by 4 in each group to figure out how many groups I need. So I'm going to split it. 1 group of 4, 2 groups of 4, 3 groups of 4. So that tells me I have 3 groups. Divided by 4 equals 3. So this is how we took the notes in class for students to make the connection between the two. And when we were done with these 2 sets of examples, especially this one because this was the second example that we did, they started making the connection that, hey, this array and this array look exactly the same. This array and this array look exactly the same. Oh, they're connected. It's just multiplication builds, division breaks it back down again. Just like addition builds, subtraction breaks it down. So that relationship can be a little difficult for students to understand, but if they're given the opportunity to look at it a couple different times, most of the time they're able to get it. So like I said, I'm going to show you the notes that we took in class. I know this is a little convoluted, which is why I made it bigger. I blow this up for students to see it better. So as I said before, we had the 4, 3, and 12 example, and we also had an example for 9, 3, and 27. And on this example, I actually flipped the models a couple different ways to have them start recognizing that the arrays can be written in different ways, but it's still going to be the same fact family. Just because you draw it different is not going to change the outcome. So allowing students to keep the models the same for the first little bit is good, but also work with your students on different ways that they can draw those equations in order to make those further higher level connections. I think that is it for our fact families today. Thank you so much for joining us. I hope that this has been helpful. I hope that this helps you help your students at home. And if you have any other needs, please feel free to let me know. Have a wonderful day.